This is example 4.4 from Discovering Design with Chemistry by Berean Builders. And before we start on the problems, we want to look at the periodic table of elements. Let's go ahead and label it. You can do this if you have the periodic table printed for a test before you start working the problems. So we know that this last column has our noble gases that have the perfect little electron configuration with full orbitals, and they're happy and they're noble and they don't interact with the others, right? So we're not going to look at that one. But this one right before it has 7 valence electrons. It's in column 7A or group 7A. And so if it could get one more electron, it would be like the noble gas. And so by gaining one more electron, it becomes an ion with a -1 charge. The next column over, group 6A, is 2 away from that. If any of those can gain 2 more electrons, they would then have the complete field. And so when they become ions, they gain 2 and have a -2 charge. And then so on as we go over. On the opposite side of the table, we have group 1A that just has one too many. If they could lose one, they would have that nice configuration. So when they lose one electron, they lose something negative and they become positively charged. So we have a +1 charge to these ions. And in the next column, we have 2 extras that we want to lose. And when we lose those 2 negative electrons, the whole thing becomes unbalanced in that it has a +2 charge. And then we skip over to group 3A. Don't worry about this group in the middle. They don't work the way the others do. We end up with a +3 charge. So the positive charges are cations. And I like to notice that the T in the middle looks like a positive sign. And the negatives are anions. The N in the and part is like for negative. So if that helps you a little bit to remember which is which. Then good. All right. So the first question says, what is the chemical formula and name of the ionic compound formed between magnesium and fluorine? Because these are both ones that we have learned, we can find them quickly on the table and see what their charges are. So magnesium is in group 2A. When it becomes an ion, it will have a +2 charge, and fluorine will have a -1 charge. So let's write those. So magnesium will have a +2 charge, and then fluorine will have a -1 charge. To write this as an ionic compound, we just swap those things. If it's a 1, like in this case there's only 1 magnesium, we don't need to put a 1 there. We can just leave it blank. And to name it, we keep the first element, the cation, the same. And then the second one, the only thing we change is the ending. We just change whatever the ending is to "ide." All right. The next one says, give the name and chemical formula of the ionic compound that is formed between aluminum and sulfur. So now we've got to find those two. So here's aluminum right here in the +3 column, and here's sulfur in the -2 column. When we put those together and we swap the numbers, we get aluminum 2, sulfur with a 3, and we name it aluminum. And the second one we call sulfide. So aluminum sulfide is its ionic compound name. All right, and then the last one says, what is the chemical formula and name of the ionic compound that forms when calcium and selenium react? Now, calcium is right here. We know that one. But we don't have selenium necessarily memorized because it wasn't expected. You might, but probably not. So they had to give us the chemical formula of it so we could find it. So calcium is in group 2A, so it's going to have a +2 charge. And selenium is in group 6A, so it's going to have a -2 charge. So those two end up having the same charges, and you can write them down and see, but whenever they have the same charges, that means they balance each other out when they go together, so we don't have to write anything. We can just, looks like I wrote a word there, so we can just list them like they are. So calcium, and then selenium, we're going to change that last little piece to ide. So calcium selenide. Actually, I'm not sure if I'm pronouncing that right, but as long as you get the chemical symbol right for the ionic compound and you get the name right, awesome.